Alright, we're beginning. Good. See Nicholas.
Morning, sir.
Good morning, you lovely people. How are you guys doing this new week? Alright, cameras on from everybody. Today is going to be an exciting class. Good morning, Nicholas. Today's going to be an exciting class. You know why?
Why?
Because we're going to distribute happiness. That's a joke. That's a doing distributive law. But we're going to distribute some numbers and practice distributive law. Then we're going to move on to the new topic. Alright? So I have two questions on the board, and I want two awesome persons to try and attempt these questions. Anybody here is awesome? Let's see. Alright, I hear somebody wondering if they're awesome. Is that Nicholas?
Yes, sir.
Alright, so Nicholas is our first contestant. He's gonna try question 1. I want another awesome person now. Who wants to try question 2? Go to the board. Good morning. So, there's a lot of you guys today, and that's good. That's good. Alright. So, as I said, we have two awesome questions on the board, and I want two awesome persons to try. The first one is going to go to Nicholas. Alright? So, Nicholas, follow the steps with me now. We have a question on the board. Alright? It says we have 3 times. Good morning, Jazeel. We have 3. So, guys, remember, cameras on for me, please. Thank you. Cameras on.
Sorry, I know the answer.
You know the answer. Okay, good.
It's 33.
Wait. So remember, we're gonna take the 3 and we're gonna multiply. Wow, we're gonna multiply.
Wait, no, you don't multiply first. So you add 4 plus 7. That's 11, and then you multiply by 3, and that's how you get 33.
That's a good attempt, but remember, to prove distribution law, we said that you always multiply the outside by the 2 terms. Isn't that right? So you could have do it that way, Nicholas. But I want you to try and multiply the 2 terms by the 3. So what would be here? If I say 3 times the first term, what would I have? 3 times what?
It would be 12 plus 7.
Wait. So it would be 3. Everybody paying attention? 3 times 4 plus, what would be now 3 times the second term? What is the second term?
It would be...
What's the second term, Nicholas? The second term is?
It's 20...
So Nicholas is a genius. He's trying to work out the question. But remember, I'm asking you firstly, before you work out the question, what is the second term exactly?
The second term is 21.
Alright, the answer is 21, but the second term was 7.
3 times 7.
Right, there you go. So he got it right though. He said that you're gonna get 4 times 3 plus, you put the plus sign, because the plus sign comes from this section right here. You're gonna say 3 times 7. So Nicholas said 4 times 3 gives us 12, right? Plus, he said 3 times 7 gives us 21. So now our job is to add 21 plus 12, and tell me what you get, Nicholas. What does 21 plus 12 give you?
That's it's 33.
33. Alright? So therefore, the answer is 30.
Sir, that's just a longer way of doing it.
Yeah, but we need to prove the distributive law. That's why you're going to do it this way. Because the other way would have been incorrect based on what you said. It would have been 11, not 10. You said it was 10. So 4 plus 7 would have been 11. And then you multiplied 11 times 3. Alright? That would have been the other way. Now let's move to question 2. And I want somebody to try it. Let's see. Cassania, you're the next awesome person. Are you ready to try question 2?
Got 29.
Wow. Okay, take me through the steps. The first term and this. What is the first term? We have 4 times what? 4 times 8. Right? And what is the operation between the first and the second term? What operation is there between the two of them?
Multiplication.
No. So this is the operation on the 4, but in between these two terms, what do you see here?
Subtraction.
Subtraction. So we're going to say 4 times 8, carrying back the subtraction. Let's put the subtraction here. We're going to say now 4 again times 3. Alright? So we're going to say 4 times 8 minus 4 times 3. So what is 4 times 8, Cassandra?
32.
Everybody see that? 4 times 8 gives you 32. Carry back the minus. What is 4 times 3?
12.
12, okay. And now we must find what is 32 minus 12.
20.
Alright, so the answer therefore is that 4 bracket 8 minus 3 gives us 20. Everybody take that off for me? So those are the 2 practice questions for distributive law. Alright, now that we've completed this, we're going to move on to a new topic. But just before we move on, are there any questions about the distributive law? Any questions? Alright, no questions? Okay. Alright, can I rub off the board?
Yes, sir.
Alright, let me quickly take a picture though, just to make sure. And I don't want anyone to say, sir, I wasn't finished. So I'm going to take a picture of the board and then send it in the group later on. Alright, here we go. Okay, good. Now, the next topic that we're going to go into, it talks about the fact that you can really make more than one operations in a single symbol. And I'm going to explain that. So if I said, let me quickly write down the board. If I gave you something like, let me check quickly. If I gave you something like this, let's say, Kai, that I gave you this question. 8 divided by 2. What is the operation between those two numbers, Kai?
Division.
Division, right. But did you know that you can define what this is? Math says more than one things can be represented by just a division sign. Let me explain. So when you see the division sign, you must state what you want it to represent. So you're going to say, for example, this operation, let me put it over here. So everybody got this with me? This operation, so we're going to give it a new meaning. Alright? We're going to define what it means. So this operation means subtract 3 from the first number Alright, we have Ludi. Alright. So, we're going to give it a new meaning, and we're saying that this operation right here, we're going to say it means to subtract 3 from the first number then add the result to the second number. My apologies. To the second number. Alright? So we're going to break this down step by step. If the first instruction was for you to do what? Subtract 3. So highlight that for me. Subtract 3. What was the second instruction? And this question goes to Pale. Pale?
I can't read it.
Oh, it's too blurry. There we go. So it says this operation, wait, my bad. This operation means subtract 3 from the first number and then add the result to the second number. So what's the second operation?
Add the result.
Right. So we're gonna highlight add the result. Add the result. Okay. Now, the two boxes that you see me highlighting, we're going to now put it inside as a math statement. So firstly, I want to call on Jazeel, and I'm going to ask him, what was the first number?
3, sir.
No, over here, in this statement right here, 8. So we're going to write the first number 8. Right, and Jazeel, what does the first box say? This operation means subtract 3 from what?
First number.
So we're going to say 8 minus 3. And we're going to put it in brackets. Right? Because that's something happening by itself. Alright, now Jazeel, pay attention for me now. What is the next instruction? It says, then add the result to which number? So I'm going to put down the second number, and add is a plus sign. So I'm going to put the plus sign right here. Alright? So this came from just this symbol. So we defined what the division symbol is, and that's our topic. We're going to call it defined arithmetic operations. Alright? Let's write the topic. Defined. We gave it a new meaning, so we defined it. We're going to call it defined arithmetic operations. Defined arithmetic operations. Alright. Okay, now, does anybody know what BODMAS means? BODMAS?
Brackets.
Right? Let's first write the acronym. It's an acronym. So we're going to first write what the B stands for, what the O stands for, what the DMAS stands for. So let's write B. B stands for what? Bracket. Excellent. Who said that?
I did.
Who's I?
Azura is I, sir.
Okay, good. So Azura is correct. B stands for bracket. Alright, Azura, what does O stand for? Over. Excellent. Alright, let's give somebody else a try now. We're gonna call on Lud. Oh, Ludi is not even connected. Let's try Khalil. Camera on for me, Khalil. Kimani, camera on for me, please. Thank you. Alright, let's call on Kimani while Khalil is getting ready. So, Kimani, are you there? We're gonna write the D now. What does the D stand for, Kimani? Is Kimani there? Alright, he's not there. I'm gonna put him in the waiting room. Once he's back, you just message me in WhatsApp. Let's put him in the waiting room. Let's call on Kai. Kai, are you there?
Yes, sir.
Alright. So D, what does D stand for?
Division, sir.
Division. Alright? Division. Alright, don't go yet, you have one more. What does the M stand for?
That's multiplication, sir.
Right, multiplication. So we're going back over these operation symbols. Alright, thank you, Kai. The next two, we have A and we have S. The A stands for addition and the S stands for subtraction. So the least important operation is the subtraction. Alright, if you haven't had this down, take it off of me. So the most important, the one that comes first is bracket. The one that comes second is division. The one that comes third is multiplication, then fourth, addition, and then fifth and least important is subtraction. So let's look at this question now. Kai, what would be the most important thing I need to work out based on BODMAS?
8 minus, wait, hold on.
Don't be,
Oh, wait, sir, no, 8 minus 3, sir.
right, excellent, be confident. So we're going to work out the bracket first because that's the first thing. So what is 8 minus 3?
That's 5, sir.
5. Alright, do we have any other operations? So this is the workout for the 8 minus 3. I'm going to carry
No, sir, we don't have any other operations.
right, so we're going to carry back down the plus 2. And now because there's no other operations, we're going to jump all the way to the fourth rule, which is to add. So we're going to add 5 plus 2. What's 5 plus 2? 7. Right. So this is the principle of defined operations. So I'm going to give you some notes now. So take off this example, take off the BODMAS, right? And now we're going to write some notes. Alright? Now let me sit right in front of you so you can pay attention. Quickly look at this one now. Defined operation. Let me just check if Kimani is not back. 1 second. Alright, he's not. Alright, I don't see him in the waiting room or anything. So I'm going to reach out to him. Okay, let's continue. So, defined operations, defined arithmetic operation says the following. Can I have off the board? Can I have off the board, guys?
Yes, sir.
Alright?
Yes.
So, it says, apart from the 4 basic operations, we can create alright, so for those who might be having internet issues, don't worry, the class is recorded. Alright, I see Ludi has internet issues. Okay, so it says, apart from the 4 basic operations, apart from the 4 basic operations, guess what? Let me go over a little bit. There we go. We can define many more operations in arithmetic such as the one we did. Such as the one above. Okay, good. Alright, so let me just check if that's Kimani. No, that is not Kimani. Alright, let's continue. So we're going to do one more practice, but this time it's going to be you guys answering. Alright, so let me write the question on the board, and then we're going to take turns answering this question. So here's the question. It says 5 divided by 1. So write the question. We have 5 divided by 1. Right. Have I given it any meaning yet, or is it still just a division sign? Did I write anything over here yet about what division might mean?
No, sir.
That means I haven't defined it yet. So I must write what exactly is represented by this division sign. That is how you give an operation definition. So here we go. This division symbol, alright? 1 second. Let me give you another one. I want to use multiplication. So sorry about that. Let me use multiplication this time. Let's say 3 times 1. Here we go. 3 times 1. We're going to give this multiplication now a new meaning, and here's what we're going to say. The operation in bracket or in quotation, so we're going to put the symbol, means multiply the first number by 5. Multiply the first number by 5, and then subtract the small number, or the second number rather, from the result. Okay, now, same as we did before, I'm going to call on 2 persons to highlight the 2 things you see coming out. So, like we did before where I highlight operation, I want Emma and Harry. What is the first thing that this says we should do? Let me highlight it for you. What should I do, Emma? Let me read it one more time for you. The operation in bracket multiplication means multiply the first number by 5 and then subtract the second number from the result. What is the first thing it tells you to do?
Multiply the first number.
So we're going to highlight that. So let's highlight that. Multiply the first number by 5. Here we go. Thank you, Harry. And now we're going to go to Emma. Emma, are you here?
Yes, sir.
Alright, so Harry told us the first operation. What is the second operation, Emma? So let me read it the entire. Yeah?
Sir, subtract.
Subtract, but subtract what? Read the entire line. Subtract what?
The second number from the. Sir, what's the last?
Result. Put it closer. So it says subtract the second number from the result. Alright, those are the 2 things that are coming out of this one symbol. You're going to first multiply by 5 and then subtract by the second number from the result. Okay? So let's do that first thing. So Emma, what is the first number in this question right here? What is the first number?
3.
3. So we're going to say multiply 3 by 5. Because it says multiply the first number. So we're going to say 3 times 5. Alright? Now Harry, still with you, Harry? We're going to put a bracket right here to show that this is the first thing. Harry, what would I put here now? It says, and then subtract what from it? So, what would I put here, Harry?
-1.
-1. Excellent. So this came from just this one symbol. So let's work it out together. Emma, what is 3 times 5?
15.
15. Alright, and I'm going to carry back down the minus 1, and 15 minus 1 gives me 14. So this is very simple, but the idea behind it is there. 3 times 1 was our original operation, and we know that would have given us just 3. But because we gave it a new meaning, right, the new answer is 14. So that's the difference, alright? Write this example off for me, and then now, let's see how much time we have. See if we can do one more. Excellent, we can. And then we're going to go through another topic. So quickly write this down for me. Any questions so far? Any questions? No questions? Alright. So, this topic I'm going to go through now, I have wanted to go through it, but we never could find the time. But here we are now. We're going to go back into factors. Because what I see happening, when we did fractions last 2 terms ago, we didn't get to go in depth as we wanted because some topics under fractions relate to other types of numbers such as factors. Alright? So we're going to go through factors of a number right now. So if you finish writing off the board, which I'll take a picture of, we're going to write that for me. Factors of a number. I'm going to take a picture of the board first for those who are not here. Alright, good. And let's write factors of a number. Alright. I'm going to ask one person while I'm doing this to just quickly tell me what you remember about factors. Let's ask Jazeel. Jazeel, what's a factor? Jazeel?
Yes, sir.
What do you remember about factors? What is a factor?
Sir, it's that the
Alright, let me give you an example. A lot of the times I forget English too when I'm doing math because math is better than English. So let me give you an example and just tell me what's happening. Alright, here we go. It says find the factors. So let me write the topic. Factors of a number. Factors of a number. Alright, here we go. So it says, question 1. Find the factors of 40. Alright, Jessica, tell me now, what does this actually mean when it says find the factors of 40?
Many numbers that can go into 4 that can give you 46.
Right. Numbers, no. So it's really asking you to find numbers that can go into the number 40 and not do what? Not leave a remainder. Isn't that correct? So, the first factor of 40, let's try the number 1. Let's see if we divide 40 by 1, if we get a remainder. Alright? So we're going to say the number 40 divided by 1. Alright? What is 40 divided by 1? This question goes to David. David, are you there?
Yes, sir.
Right. What is 40 divided by 1, David? What would I give you? It's a trick question. 40 divided by 1. So let's say I have 10, 40, right? I get back the number itself. Is there any remainder? No. That means 1 is a factor because I have no other remainder. There's nothing else but the answer 40. So for the factors, the first factor I'm going to write is 1. Come on, let's try to find some other factors of 40. How about 2? Let's try 2. This question goes to Kisani. Kisani, how many times Or what is the value for 40 divided by 2? What's 40 divided by 2? Can you repeat that?
Exactly if you just said.
Oh, I said what is 40 divided by 2?
20.
20, right. Is there any remainder, Cassandra? Any other values that's left? There's no other remainder because I didn't have 20.2, for example, right? None of this. So that means that 2 divides 40 exactly. There's no remainder. So that means 2 would be my second factor. So 1, 2. Let's try a larger number. Let's try 20. Let's say 40 divided by 20. This question goes to Ludi. Oh, Ludi is having internet issues. Khalil, what's 40 divided by 20? Khalil? Alright. Guys, I always spring surprise question. I say must pay attention. Alright, I'm gonna check back on Khalil. Let's see. Ask 0. What's 40 divided by 20?
40 divided by 20
Yes. How many times can 20 go into 40?
times.
2 times, right? And there's no remainder. Okay? Now that is another factor. We're gonna say 20 is another factor. But let's prove what wouldn't be a factor, because all we've been doing is just factors of 40. Let's try the number 7. Let's try the number 7. And this question goes to Pale. You get the hardest question. What is 40 divided by 7?
4, wait, 5, 7 times 5.
Can you repeat that for me?
Wait, can you repeat the question?
How many times can 7 go into 40? Let's do the long division. We have 7, right? We have 40. 7 into 4 goes how many times?
0.
0. So I must pull on the second value. So 7 into 40 now goes how many times?
5.
5. Okay, excellent. Alright, and we're gonna multiply the 7 times 5. What is 7 times 5?
35.
35. And we're gonna subtract it, isn't that correct? What is 40 minus 35?
5.
5. So, in this scenario, we have a remainder of 5. Okay? That means 7 is not a factor of 40 because our answer is actually 5.5. Alright? We have a remainder of 5. So, that is an example of a factor that is not, or a number that is not a factor. Everybody understand? Okay? Good. So that is what I wanted to go through and really get you guys to feel comfortable with. I'm going to give you some past questions now to practice. So just to be clear, all the factors of 40 are not just 1 and 2 and 20, but rather you have 1, comma, 2, comma, 4, comma, 5, comma, 8, 10, 20, and 40 itself. These are all the factors of 40. So write that out for me. And using this idea, alright, you're going to now find the factors of the following numbers. Okay? Here we go. You're going to find the factors and show working. So to show you working, the way I did it was to say 40 divided by 5. Using long division, I say 5 into 40. Alright? And then I followed what the remainder was. That's how you prove or show all working. So when you're finding the factors, this is what I want you to do. Everybody clear on that? So here's the second question. It says, find the factors of 36 and 50. That's your homework question, everybody. 36 and 50. Any questions about factors of a number?
No, sir. I
Can you repeat that for me?
Sir, I just said I don't need help with it. That's all. I don't have any questions.
I didn't hear anything you said. You were breaking up. Repeat that for me.
Sir, I said I don't need any help, and I know how to do the questions.
Okay, good. So, I want to just use this opportunity now to just go back over quickly of square numbers. Alright? So, that's the next thing I want to really catch up on. Square numbers. Square numbers. So, write it for me. Square numbers. Alright, now when you hear the word square, a diagram comes to mind, right? Isn't that correct? A diagram comes to mind. So, what square numbers actually mean? Write this for me. If I had, for example, 4 squared. Jazeel, can you remember what does 4 squared mean again? What is happening? We have 4 and it is raised to a power of 2. What does 4 squared mean again, Jazeel?
8.
Wait.
No, 4 squared
16. So the rule is when you have a squared number, you really have the number multiplying itself the amount of times that's in the power. So if it is 2, that means the number is multiplying itself twice. So we have 4 times 4. Alright? Now, let me show you how you can represent this using a diagram. So we have 4 squared. Here's what we're going to do. I want you to draw now from it 4 dots going across. 1, 2, 3, 4. 4 dots going across. But I also want you to draw 4 dots going down. 1, 2, 3, 4. Now I'm going to call it after 0 because I'm betting she sees what I am trying to show you. After 0, what do you think I mean when I say that 16 can be shown on a pattern? What do you think we're going to do here in these sections?
Dots. Like, right.
Can you repeat that for me?
Right, 16 dots to represent the 16.
Excellent. So what I'm going to do now, I'm going to show you what actually happens when you say 4 squared. So picture you have you guys haven't done Cartesian plane, but picture you have a line that is 4. Right? You're going to put 4 there for me. And then picture you have a line going across that is also 4. So let's say this line represented 4 students waiting for the tuck shop to open. Alright? And let's say this line represents another 4 students waiting for the tuck shop to open. So they're waiting for this tuck shop in 2 different lines. Alright? Everybody clear on that? But let's say that behind every student there was another student. So let's draw those other students. So there's a student behind at 0. This is at 0. Student there. There was a student behind Jazeel. Let's put him there. There's a student behind Payal. There we go. There we go. There we go. And there we go. There was a student behind Nicholas. There we go. There was a student behind Cassania. There we go. And there was also a final student. And he's Mr. Thompson. He was behind everybody else because he is a student as well. Alright? So that's a joke. Let's load it up again. welcome back everybody. Let's quickly finish. So let's say now this is our new diagram for everybody that's in this line. Alright? What squared number says is that given that you know the amount of persons that are standing vertically, let me draw this a little bit better. Given that we know the amount of students that are going vertically and we know the amount of students that's going horizontally, one second, there we go. So given that we know these students, which are 4 times by 4 by 4, the power of a number says that all you need to do is to multiply 4 by 4 to find all the students in the line. Alright? So 4 times 4, you said gave me 16. Let's prove that there are 16 persons in this line. Alright? I want just you to count with me. We have 1, 2, 3, 4. 1, 2, 3, 4. That's 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? This is the power of a squared number. So I want you to write this in summary. If you haven't taken this diagram off, quickly take it off for me. Alright, and here's the summary for a squared number. Alright, so in summary, a squared number is a pattern which can be represented by dots in the shape of a square. Any questions? That's what squared numbers actually mean, right? It's really just a number, but you can represent it physically in a square and find the actual number. Alright? So if they ask you to find 2 squared, you know it's going to be 2 dots going across, 2 dots going below. There we go. So it's 1, 2, 3, 4. 2 squared does give you 4. Everybody understand that? So with that said now, here's your homework questions. If you have this book, I'm going to take a picture of it, but here's the homework questions. You're going to do question 1 to 3. Questions 1 to 3 in page 21. Page 21. 1 to 3. But I'm going to take a picture of it and post it on the portal as well as in WhatsApp. Any questions before we go? So today we learned factors of a number, defined arithmetic operations, and square of a number. Alright? Please ensure you revise and do the homework. If you have any questions, just message me or email me and I'll help you.
You're going to send a picture of the homework, right, sir? Because I don't have the book, sir.
Yeah, I'm going to post it in the group right now. So just tell me if you see it before you go. 1 second, I'm just posting it. Alright, so let's check the group for me now. I'm going to send it right now. Alright, here we go. Oh, by the way, I must commend you guys on your exam. Alright, I don't think I told you, but all of you guys did exceptionally well. All of you, compared to the previous term. Everybody got an increase in their grade. Alright, so check the group for me now. Wait, I think that's wrong.
I don't see it yet.
Alright, 1 second. I think the Wi-Fi is a bit slow. Alright, do you, let me take a picture again. 1 second. 1 sec. Alright, there we go. Check it for me now. 5, 4, 3, 2, 1. Do you guys see it now?
Yes, sir.
Alright, so questions 1 to 3. Define arithmetic operations. So have a great day, everybody. Take care.
Bye, sir. Have a nice day.
That was a great class.